So we have y equals tangent of x, and then they also give us this information off to the side that x is sandwiched between negative pi over 2 and pi over 2. So that's kind of like, oops, that's pi over 2, sorry. That's kind of like piecewise function notation. It's saying we're only graphing this between negative pi over 2 in the x-axis and pi over 2 in the x-axis. So let's see, how do we show this for all values though? One second, I gotta think about it. Okay, so to show it for all numbers, you'd have to prove that tangent of x sub 1 never equals tangent of x sub 2. Two different values of x can never have the same output. You plug in like this is a y value, right? And this is a y value. So to show that a function is one-to-one, you need to show that that you can never have two y values that equal each other for all values of x on this interval. So that's a little bit beyond the scope of this course. I think it's enough to show it graphically. Let's just plug in negative pi over 2 in for tangent. And we've got our calculators that can work in radians, but it's good to know how to do this without a calculator too, okay? Because negative pi over 2, that's a negative 90-degree angle, so that ends up right here. So if you're trying to find a value on the unit circle, if you're trying to resolve tangent, you can't draw a triangle if this is the terminal side, right? So this is one where you have to remember the I guess it's not a definition, but it's remembering what the coordinates in the unit circle can tell us. Okay, cosine is always the x coordinates on the unit circle, and sine is always the y value in the unit circle. Like if you plug in your calculator right now, sine of 0, you're going to get 0 because the y coordinate here is 1 comma 0. Sine is the y coordinate on the unit circle. And if you plug in cosine of 0, you should get out 1 because this is a unit circle. It's got a radius of 1. So 1 comma 0 should be your answer when you plug in cosine of 0. And then if you plug in sine pi over 2, you should get out 1. If you plug in cosine pi over 2, you should get out 0 because cosine is always the x coordinates on the unit circle. And tangent, this feels like a really long explanation, sorry, but tangent is sine over cosine. It's another way of writing tangent. And so at negative pi over 2, we're here on the unit circle. We're at 0 comma negative 1. So 0 for cosine, 1 for sine. So 0 for cosine, 1 for sine. So that's undefined. That means you have a vertical asymptote. And then if you plug in tangent pi over 2, you'll have another vertical asymptote for the same reason, because that's a 90-degree angle, but the x coordinate is 0, the y coordinate is 1, so that means cosine is 0 and sine is 1. So you've got a 1 divided by 0 issue again. Now, do you hit the vertical asymptote like this, or do you hit it like this? That's where you need to test out some other values. So like halfway between, we could do negative pi over 4. If you draw negative pi over 4, negative pi over 4 is a 45-degree angle, and since it's negative, it means we're going backwards this way. So there's where negative pi over 4 is. It's a 45-degree angle. And if you remember 45-degree angles, if you draw them in the unit circle, that means the hypotenuse is 1. And this is easy to remember. It's the same sides for both, because if this is a 90-degree angle, they both got to have same angles, and therefore the sides are the same. So we've got square root of 2 over 2 for both sides. And tangent is the opposite of your reference angle divided by the adjacent of your angle. So negative square root of 2 over 2 divided by square root of 2 over 2 gives you negative 1. So tangent of negative pi over 2 should give us negative 1. Let me think that out. Did I do that right? Yeah. So at negative pi over 4, we should be down at negative 1 on the y-axis, and there's our dot. Okay. If you do the same thing, if you do pi over 4, you should get out 1 for a dot. If you do tangent of 0, you should get 0 when you resolve that. So the graph should be a curve like this. Never hits those vertical asymptotes, but gets really close. That's how to do it without a graphing calculator. And that's passes the horizontal line test, so it's 1-to-1. Okay, that's a lot of talking just for doing it without a calculator, huh? But we're asked to graph the inverse. So a quick way of graphing inverse functions is to make the y equals x line, because x is what you're supposed to get out. The identity function is what you're supposed to get if you put two if you put an inverse into the original function. So if we're graphing an inverse, it should be doing the exact opposite on the other side of the function. So here, if I start here at negative pi over 4 comma negative 1, then I should be at, oh wait, that's at y equals 1. So if this is, is there a way to quantify this distance from here to here? Well, you could just guesstimate it. This is this red vertical line I'm drawing is from the y equals x line to negative 1, which actually it should cross right at negative 1, right? Y equals x has, oh no, sorry, I'm wrong. It's because that's negative pi over 4. Okay. So look, we're this distance away from the vertical line, so we should be the same distance away above from, I said vertical line. Let me say that again. We're this distance away from the diagonal blue line, so we should be the same distance above it. So roughly right here is our dot of our inverse function. And then we both cross here, and then we need to be doing the mirror image on the other side. So you should be drawing a graph that's doing the opposite as this graph around the y equals x line. So something roughly like that. Probably needs to dip harder though, like something like that. Okay, so that should be a graph of the inverse. But you could always graph the inverse real quick. We have a button on our calculator for that. The inverse of tangent is arc tangent, or sometimes it's written like this as a little shorter notation. Either one of those, that's the inverse of tangent.